So there are a very small number of water molecules that are actually going to break up in any sample of water. When it breaks up, if you remember when we put together water molecules, the hydrogen atoms came to that bonding structure with an electron. Every hydrogen atom had an electron, and they shared the electrons right here, creating this bond where they shared the electrons. But when the hydrogen atom leaves, it leaves without that electron. So when it leaves, it doesn't have an electron. It means it has a positive charge. It has one proton and no electrons to counterbalance the positive charge of the proton. Since it only has a proton, it is a proton. So when hydrogen dissociates from a water molecule, you create a hydrogen ion. Okay? The other part that remains then is called an hydroxide. A hydroxide ion. One of these two electrons here is one that the hydrogen left behind. So this structure here has an extra electron. And electrons are negatively charged, so the whole structure has a negative charge. This negative charge is shared through this whole ion. And this is called a hydroxide ion. It's in your test references listed in your common ions list. And I'm going to flip the page because this is also in this unit handout. And you'll find hydroxide right here. Okay, OH negative. So when we write it as just a formula, a simple formula, it's just OH negative. Okay? All right, so let's go back here a minute. Now the hydrogen ion that's now freely floating around or bouncing around in the water, it wants two electrons. It left behind its two electrons, but it really would like to have some electrons too. So some of those hydrogen ions will actually share a pair of electrons. Andrew, would you open the door over there, please? Will actually share a pair of electrons on this water. So some water molecule that wasn't one of those that broke up will actually join up with this hydrogen ion. And in this case, I think I've shared it down here. And it reforms or forms a new kind of covalent bond with that water molecule using one of those lone pairs on the water. And when it does that, it makes a new kind of polyatomic ion called hydronium. This is called hydronium. And it's got the brackets around it and the plus charge outside because the hydrogen ion joined on a neutral water. So this structure has a plus sign, a positive charge. And the whole thing, all together, is sharing this positive charge throughout the whole molecular structure, this polyatomic ion structure. Okay? Now, this is new in this unit. This is reminders or going back through things from the previous unit. This is also from the previous unit. And this is showing what happens when you have an ammonia molecule dissolved in water. Those hydrogen ions from the dissociation of water are available. That proton then can share this pair of electrons, just like it shared this pair of electrons up here. The hydrogen ion can share this pair of electrons in a covalent bond. And we can create ammonium, an ammonium ion. Since ammonia is neutral, you bring to it a positively charged particle and covalently bond that particle. The resulting particle, the ammonium ion, has a positive charge. And that positive charge is shared through the whole thing, and that's what the brackets with the plus sign outside will tell you. Okay, so this is review, and just adding on to the same stuff. Same concept, just a new set of structures here we're talking about. Okay? And then the next few pages are totally review. It's all about the polyatomic ions you learned in the last unit, how to name compounds. This is all about how to name compounds. This is page 5 of your unit handout. Page 6 is about naming compounds. These are the prefixes for naming covalent compounds. Those are the non-metal bonds, except for we're about to get into organic, which is kind of new. Let's see. Binary compounds always have an IDE ending. We looked at that in the last unit. Okay. And then naming acids is down here. Here's sulfuric acid. Shows how to name sulfuric acid. We did that in the last unit. So it's a chance for you to review those things you didn't do so well on this test you're about to get back today. Okay. All about the suffix "-ik" and "-ite" ionic 8s, when you're doing acids. Okay, all of that's in there, and then there are some practice problems at the end, so you can practice and see just how well you have a grasp of the whole subject matter. Okay?